we are going to enable this particular project, or rather a demo on a GitLab. So what we are doing is we are using the GitLab pipeline over which we have deployed few jobs or configured few jobs, Terraform jobs. What we are doing finally is we are going to provision, what? Provision a VPC. VPC is a network element over the cloud. Other than the default VPC, which we already have for a particular region like Mumbai, we are working on Mumbai. We have this IAM user, which is DevOps Internship, which we have created earlier. Okay. Besides this, we want to have our own VPC setup. I'm going to have my VPC with a particular CIDR. Okay, but I will not go into AWS Cloud and do it manually. Maybe I am not being authorized to do anything on the from the console. Okay, so what I do, I have created a pipeline on which I have put in few jobs created over the Terraform scripts. I'm going to run them automatically, one after the other, this particular jobs through these stages. The one that is marked as red is the stages, and the one that are already run as a picture, these are the jobs. Once this is run, you will see a VPC has been created. That is what I'm going to demo. Now, as we have seen that we need a runner, because we are doing a self-managed GitLab runner. We are not using the software as a service, GitLab I will manage services. We are not going to that because that is costly. So we want to save the cost. We have created our GitLab runner, and that runner is going to run with the executor as Docker. So we see that I would like to check whether my Docker is running in the background. Yes, my Docker is running in the background, which is active and running. Fine. So based on this Docker, which is a containerization tool, I am going to use a pipeline runner. The runner is the one utility of GitLab which will execute the jobs, but on top of the Docker as the container ID, the container D, the daemon. Okay, so this must be on. Now I will go to check my VPC. I'm going to check the VPC service of the region called Mumbai. It can be any region. Any region will have their own VPC. So I'm going to my VPC for the Mumbai region, and I find that there is a default VPC. That's fine. That is the default architecture. Okay. Keeping this in mind, I will now go to my GitLab. Okay. So see, this is your GitLab interface. It is very simple. It is not cluttered, but it has a lot of power. Okay. So while we see, you just have to, as I said, that GitLab is an instance or somewhere on the cloud. You need to it is absolutely free of cost. We have created our project. So many projects have been done. Okay, but I didn't have to pay a single cent to GitLab or to anyone else. I am creating a project. Okay, so this is my interface. I just have to create. I created my account. That's all. You will have to also just have to create your account. That's all. That is what is needed. That's all. You on the cloud, you have an account. On Docker Hub, you have an account. On GitHub, you have an account. So this is same. you just have to create an account and start working. So let's say I have I have built in everything for this. So this is a new project. So the projects can be created very easily, going to the new project icon. And there are 4 ways that you can create a project. You can create a starting from the scratch, that is a blank project, or you can use the GitLab template. For that template will help you set up the project and this configuration very easily. You can use a template. Or suppose there is already a project built in and you are doing a similar sort of a project, but nevertheless, to say it is not exactly the same, then why should you do it? So you are importing a project, you are cloning it, and you are going to modify the project according, you adapt that project into your requirement, the current project requirement. That is another way. And the finally is you can directly run a project from an external repository. So the pipeline will be given by GitLab, but your repository will be given by, let's say, GitHub. So all the resources, the software resources will be there in a GitHub repository or Bitbucket repository, and you are just using the pipeline from this and running a project from the repository there. I am just going to create a blank project. It is already created for you. It is the simplest way of creating. So I can just show you. When you create a project, it will ask for the project name. You can give any project name, any combination, capital letter, small letter, doesn't matter. But whatever you do, it converts the project name into the project slug. So that slug is nothing but your project repository. As I told you, GitLab is not only a pipeline software, CI/CD pipeline software. It is also a version control tool where you can have your project repository. And not only a version control tool, it can behave as a GitHub. It can also be your project management tool like Jira. And also it can be your, you can monitor, you can secure, you can inbuild the security, and you can do a lot of things. As I told you, there is a code review. So these are the quality features that is already inbuilt. It's a big, big bonus that when you use GitLab. Anyway, let us go back to the projects. I similarly have created a new project called GitLab Terraform project. So this is my account and this is the project. So I click on this. I have already created the project for you, and very simple. On the left hand side, there is a navigation area where you have various things. So here are the pin, the issues, the merge requests. So the issues are whatever the issues that you are creating. It is like a storyboard. It's like Jira. And you can manage your project like Jira. You have activity members labels. Then also you can plan. It is also part of, it is like Jira, where you can create your issues. You can create your Kanban boards or Scrum boards. You can define your milestones. Also, you can have a wiki documentation, a repository, artifact repository. And then there is the code part where you have the merge request, merging the various branches, the codes from various branches. You have the repository on a particular branch where you have developed or something. There are branches that you can commit your work. These are the various things that you can do. We will learn it in our main course. There is the build. Under the build, you have the pipelines, the way you create your pipelines, the jobs, the pipeline editor, whatever. You can secure, you can apply the security, all the capabilities, audit events. You can do a security configuration. And then comes the deploy. You can use GitLab for deploying your entire project. Okay. So you can define your releases. It's basically it is on an agile project. So you have sprint releases. Okay. You can do everything, all and everything inside one tool. Then there is one operate. Under this, right now, I can go, you can operate your Kubernetes cluster if you have built in the Kubernetes. We are also going to have sessions on Kubernetes. Coming two sessions will be on Kubernetes. Then your Terraform state. This is a very important part which has been included. So you can keep your, right now, there are no Terraform state files. We are going to build that. We are going to do that in the project. So right now it is not there. But what GitLab has done, nice thing, it was lacking in so many other tools, was that it has provided Terraform with a very safe and secured place to store the Terraform state files. And that state files are the backbone of Terraform. Okay, that is one big thing. Then you can have monitoring, you can error track, you can devise the alerts mechanism, incident, service desk. So a lot of things are there you can use. You can analyze, you can code analyze you can have value stream analytics. All the analytics, even the pipeline analytics can be done that as CI/CD pipeline analytics. Repository, like how you are storing your source codes and whether they are according to the standard one. So this is, and finally the settings. I come to the settings. Access token. I have created an access token for the project. For this project, I have given this project access token because these tokens are the part of security feature of GitLab. I have created a DevOps Internship token. We are going to use that token. Then you have the CI/CD. Now this is the CI/CD pipeline environment. Remember, we have told you that unlike Jenkins in GitLab, you simply do not have to do anything. You just use the pipeline is already set for you. Just you fine tune it with few things. Like let's say the runner. You are interested with the runner. You say, Debashish, how do I make a distinction between our self-managed runner and already the instance runners available with GitLab? This is managed runners, which we are not going to use because there is a lot of dependency. Whereas we create, and these are also costly. So I have created this runner. You can create a project runner. You click on it. And you see, I'm going to create a GitLab runner on Linux. And I will be using the containerization technology of either Docker or Kubernetes. Since I do not have a Kubernetes cluster, it's fine. So either of them or both of them. Because you must know that Kubernetes also uses Docker for containerization. And so I have created a runner, and that is the runner. That is the runner. So where we go, this is the runner that we have. Can you see a green light? Because it is saying the runner is online. This was made online 12 minutes back. Did I not do it? Yes, I did it. I switched on the runner. And that runner was, you see, this was the status of the runner. The runner is running, the service is running. And that has been associated or registered with our project. So this is assigned to our project. This is our self-managed runner. Now I'm coming to all the, okay. One more thing that I need to do is, I hope you are following, though I have to rush a bit, but that is okay. Variables, the CI/CD hidden variables. These are the secret variables. I do not want to, because I'm using Terraform. Any external tool which gets into AWS or any cloud will needs an access permission, authorization permission. And through this access key, I will be allowed. So AWS CLI, through this, I was able to create. This access key is nothing but, my this DevOps internship is having an access key, the security credentials. I am putting those credentials over here. I am putting those credentials over here in the CI/CD confined or secured variable environment. AWS access key. See, I have masked it. So masking is nobody will be able to see the value. So if you go to this, see, this is masking. I can protect my value, protect my variable. So nobody can access it or remove it or tamper with it. But here I have used mask. So my access key, some value is there. I will not show you that value. Oh, it's okay. If this was a temporary user. So the user credentials are there. The AWS secret access key, the token was the project access token that we have seen earlier. And the username. The username is like, what is the account name through which you have got into your GitLab? Okay, so all these things are hidden. I will not like anybody to have an access to this. So having said, these are very minimal settings. If you have learned Jenkins, you will see how much difficult it is to set up the environment. Here it is simple. All these things are done manually. Now the main part was this. I go to my repository. I have created, see, this is my repository, GitLab, Terraform, project, DevOps, internship. Can you see a dash? Though my project is GitLab, space, Terraform, capital T, project, DevOps, internship. All these are in small letters and separated by a dash. Anyway, this is called the project slug or the repository. And under that, I have a Terraform folder where I have kept all my Terraform files. The provider file. Okay. I'm not going to do this because Terraform session is already over and we are going to learn them in our main course. Oh, this is a very interesting part. Okay, the main.tf. Very simple. And I'm just going to make it a bit large. So you can see that it is DevOps Internship VPC. What is that? This is the resource that I'm going to create, the VPC. I'm going to define the CIDR block. Anyway, that is right now, everything has been built for you. I go back to my Terraform folder, and this is the variable. It's a very, very simple project. Very, very simple project. So I have defined my 10.0.0.0/16. So this is called CIDR. I am building my own VPC network. And it is definitely on the AP South 1, which is my region, Mumbai region. So all these things have been defined. I will go back to my, so Terraform files have been defined. This is my main pipeline script. You can see. Okay. Sorry. Can you see this? I have defined the workflow, the variables, the stages. Now, how many stages are there? Validate, plan, apply, destroy. I'm doing some image. I'm using Terraform, so I'm using the Docker image. I have taken it from the HashiCorp, which is in the Docker Hub, Docker registry. All these things are there. So an image, a Terraform entire thing, I don't have to install anything. That is the beauty of containerization, and I'm using this to do my Terraform work. Terraform validate, Terraform plan, Terraform apply, and finally Terraform destroy. Okay. But these I'm doing through stages. And right now I'm putting them into manual. That means I will not allow this to run automatically because I want to have a control of it. Okay, let's see those. Everything is manual now. Manual. This section, this stage apply is also manual. And of course, the destroy has to be manual. Only when I am happy with my pipeline and the job that it just performed, I will go for destroy. So let me come back. I will go to the main thing. Uh, I will go to my build. I'm building it. I'm building my pipeline. So I clicked on pipeline. There are currently no pipelines. Yeah, I have not yet executed my pipeline. I have not yet executed my pipeline. I've just done everything. Okay. Let me run the pipeline. So running the pipeline, see, I have the pipeline script that GitLab ci.yaml. Is the pipeline running? There are there are 4 jobs. There are 4 jobs: job validate, job plan, job apply, job destroy. They are not yet. They are sequenced one after the other. First, it will run the validate, the plan, the apply, the destroy. I have also built a dependency that I cannot start to run plan unless and until validate job work. So there is a dependency. I cannot start applying unless this stage is completed. And of course, I cannot do destroy unless all these 3 are done. So this is manual. If I go, you see, validate, that job is a manual job. What I do? Okay. I could have done it automatically. There will be a trigger whenever the developer or you put in some changes into the pipeline will be triggered. Just to show you, I have not done. What I do, I validate. Before that, I go over here. You see, there is nothing. No, I have not yet created this thing. I will go and I've clicked it, manually clicked it, and I'm going to run the job. I'm showing it with each job being run manually. First time. See, it is running the GitLab runner, the runner which has been registered with that, which is running in the background for that particular instance. And you see, it is giving you the Terraform version, and it is initializing the backend. It is getting that plugins for Terraform all downloaded. And the plugins for AWS, because I'm going to see, can you see the mask? You cannot find out where this particular thing has happened, this particular log file or plugins folder. You cannot find it out because they are secured. You can never go to this particular. So I can see that it has passed. So the validate has passed. I can go to the pipeline to see this is a pipeline number. I click on it and I can I can see a holistic view. So out of this pipeline of 4 jobs, the first job has passed, validated. Now I will manually run the plan. I know you might have some questions. Please park those questions. We will attend it after we have completed. So it is running the plan job. In the stage, this is the stage, plan stage. I have given the stage and the job name the same, such that it is easier for you to understand. It is running the plan. So the job succeeded and the plan is to add one resource, and that resource is nothing but the VPC by the name DevOps Internship VPC. I will not go into the details of it, but yeah, and you can see that CIDR 10.0.0 according to your scripts has been done. So it has successfully done. So I will go back to my pipeline to see, and I find that yes, the second job after validate has also passed. Now, finally, up to this stage, now I will suddenly remember that, oh, whether my state has been created. Without a state being created, I should, this apply should all get from whatever the state plan is. So let me go and check what happened to the Terraform state. Can you see earlier the state file was empty? Now it has created a state file somewhere in the internet. It is called in the HTTP. It was updated 1 minute back. So this was just created from the Terraform states and the job. Fine. So we go back to our pipeline. And you will see we have already done the stage validate plan. I will click on this. Up to this stage, it is passed. I click on this. I will go to apply. Now, till this point, there was no VPC, no new VPC created. My mouse is doing some problem. Anyway. So I'm running this job of apply. So I'm applying my blueprint, which is the plan, such that it is physically now creating that particular resource over AWS. So this is the log file it is generating behind the scene. So, and it is a very, very nice way to see what is happening in the background. Can you see it is preparing the Docker executor? So the executor is Docker, and you can rest assured you have Docker running with the runner in the background. Can you see that this AWS VPC by the name demo VPC is getting created? And it was created. It took only 1 second to create this. So a VPC has been created. You should not believe me. Rather, I should verify it. So let us go back to the VPC, that console, and I will refresh it. Suddenly you see that there is one additional VPC by the name DevOps Internship VPC has been created just now. And can you see the CIDR? The default CIDR is definitely different from what your company CIDR wants to build. And it is not your default VPC. This is the one that you have customized, you have built yourself. And who has built this? Our pipeline jobs through Terraform. So I'm very happy that I can create it without doing anything manual over here. So let me go back. Let me go back to my GitLab. And I can go back to my pipeline. And I have a holistic view. So I'm very happy. My validate worked, my plan worked, my apply worked. So if I'm happy and I verified that my VPC has been created, okay, now my management says, okay, Devashish, you have done a very good job. It was a proof of concept that whether you are quite good at your work. So we are very happy. Management is very happy. So fine, you destroy, because it is not, there is no point. It does not make any sense to keep the resource over running on the AWS, because company has to pay for the resource getting run. So I decided, okay, management decided that please destroy the resource. So I already have the script. What I do? I just run the job. So what it is doing, it is going to use the Terraform destroy script to whatever the state file will say that, okay, there was one resource created and that was a VPC, please remove it. So it is refreshing the state and it is going to, because it is destroy, it has destroying the ID. This ID has been destroyed. Now this resource has been destroyed. It not even took 1 second. It was in nanoseconds that it was very fast. So I can go to my pipeline and see that the pipeline is entirely successful. All 4 jobs have run correctly. So I will let me go over there. I will again refresh it. What is the result when I refresh it? Can anybody tell me what will happen when I refresh it? Will I see both of them or I will see one of them? Surely I will see only one, the default one, because this was created out of my pipeline and this was destroyed out of my pipeline. So I will not see this. Let's see. Yeah, that's true. Now the other part is what we have done was I was doing everything very, I was having a look at it. I was doing everything, but finally, when I deploy it into production, so I cannot do manually all these things. I should not run it manually. What I do, I will go to my code, go to my repository. I will do a particular change to make it fully automated. So I am doing some change over here. I will edit to my pipeline editor. Right now, the only change that I'm going to do is to take out the manual part. So I'm making it entirely automatic. So I'm doing some change. This is a change on the pipeline. I'm not going to make the destroy job as automatic because I want to stop there. After I have created the resource, I want to check it. And then if I'm happy, then I will destroy it. So this is my change. And remember, if I have designed my pipeline in such a way that there is an automatic pipeline, if there is some activity, some change over onto that pipeline, immediately the pipeline will be triggered. And that is one change I have done. So I will commit the changes. And you see it is validating the pipeline. Pipeline syntax is correct. And it is checking the pipeline status. So it is triggering the pipeline. It has triggered the pipeline. So I can view the pipeline. I go over there, view the pipeline. Can you see, did I click on this? No, but it is running. See, the validate is running automatically. You can go and check the log. You can click on this and check the log. And I will not do anything automatically. You will see after validate automatically the next in the pipeline, which is the plan, will be executed. So job succeeded. Now you will see that it will be automatically changed over to you go there. You see the plan. I did not do anything clicking. I did not do it manually. It automatically started once it was correctly executed. The plan started. So let me be there. I'm not going to go to the log. You can see that the thing turned into a right sign. So the plan passed. Now it has automatically switched over to apply. It is running apply. Apply will take a bit of time because it is creating a resource. Yeah, it is done. So out of 4 jobs, 3 jobs have successfully run, and it's a very important. This is the approval stage. You know, I can switch over to destroy only once my management or the client approves. So let me go and check whether the script has been done or the resource has been created. So I will refresh it. Yes, DevOps Internship VPC has been created again automatically. And I'm happy now. So what I will do, I will go over here. I will click on the destroy. That this is manual activity because destroy is very, very dangerous thing. So you must destroy once you are confirmed that everything is working. So the destroy job is running. I can go to my pipeline. I will see whenever the job. So it is destroy running. It has done. So if I can go over there, if you go over there and you just say refresh it, the resource is gone. This was the entire demo that I was supposed to. So we switch over to Docker. Which is a very important topic in our entire DevOps journey. Okay, so which is called Docker. Let us start without much ado. Let's understand. So let's, before going to Docker, to understand what the Docker is, a particularly Docker engine, something which it's a tool. But before that, we have to know about the concept of a container. Docker is like a ship. A ship is carrying a cargo ship is carrying, you can see it is carrying a huge containers, right? From one port to the other port, correct? So you may be wondering why we are learning about container and what does that ship has to do in our DevOps journey? That is the important question, and we are going to address that. So a container is a standard unit of software that packages up code and all its dependencies, so the application runs quickly and reliably from one computing environment to another. You will not understand this definition right now. I'm not going to try to make you understand this definition right now, but just because it is a software tool, container is a software package. Okay, it it has everything within the container. Container, you can say a bucket or a huge place where you have all the environment set up for an application which can run within that environment. That environment is called container. So container images become, so I have highlighted images and container because they cannot exist. One cannot exist without the other, as if they are, uh, you know, made for each other. A container is made to hold the images, and images are there to run inside a container. What is an image then? The image is the application that we are trying to run within that container. If the image is a static image, some static application, some application, that will be considered as a static image unless and until you put that into a container. The image is nothing but a dumb thing. It becomes intelligent and it starts running inside a container. So you can say create an analogy between the container of a ship carrying some important item. Let's say it is carrying steel, it is carrying your cement, it is carrying rice, huge amount of rice to some port from one country to the other country. So that container carrying rice will be unloaded into, so that port is, one port is called platform, a software platform or a platform, an infrastructure, and it is carrying to another platform, which is also an infrastructure. You just don't have to do anything. You just have to download, or rather offload the container, and therefore because the container has the environment within it, you need some medium, and Docker is that medium to execute that container. So the images become containers when they run on Docker engine, available for both Linux and Windows based application. And not only Linux, it is available for, nowadays it is also available with Mac. Okay. Containerized softwares will always run the same regardless of the infrastructure, whether you are running it on Linux or Windows or Mac, doesn't matter, because as we said, your application which is inside a container is very safe. Like as if you are putting up you are taking up a house from California and placing it in New York without any change. The house remains the same. So if that can be done, how much effort is saved? Let us go to the next screen. So I have an image. I like to always explain through the image, because this image is going to speak about 1,000 words. I cannot keep on telling about the statements and definitions and this thing. But once you see a picture like this, most of your definitions gets very clear. What is happening? This is some, let's say this is a place. This is the Docker engine within which you have, or let's say this is a system. This is a Linux environment. And you have Docker containers. Docker containers are, you can see this is like a container, huge container. Like in India, you have seen the cargo trains, and they are carrying a huge containers. They run on the railway tracks, and you can see within few seconds they pass from your vision. They are getting carried from one station to the other station. Similarly, here also, let's say this is a container. This container is having thin writable layers, whatever it is. So container is an environment where you can made up of, so the Docker is made up of layers, a Docker image, sorry. Image is made up of layers, layer 1, layer 2, layer 3. Each of the layers is a software layer, because your image is nothing but your application. So maybe this is the operating system, a very lightweight operating system. On top of it, there is a web layer. Let's say this is Nginx or Apache Tomcat, the web layer. Then you have installed Java. This is the Java application. And on top of, you have your source code deployed. Source code maybe it's a Java Spring Boot application, the application that you have written. So the entire thing is one big image, but is very lightweight because you do not have the OS at all. But you only have the, what is that? You think this is a container, big container. Okay. The lowest layer is the boot file system on which the container will start running. There should be, see, container is after all a software package. A software package. A package can only be deployed, or it can start with some. This is the C groups or namespace device mappers, or better to say, this is an environment on which the container will start or boot. Because there is no real OS. You have the OS kernel only. Maybe this is an Ubuntu kernel, or maybe this is a Windows kernel, or maybe this is a Mac kernel, or Red Hat Linux kernel, Ubuntu Linux kernel, only the kernel. And this kernel will again have a top layer, which is the C group. C group will manage the resources. So what is the function of a kernel of an operating system? It will manage all your resources, whether it's a printer or a monitor or your keyboard or some devices, video devices, some audio players, whatever it is. It will manage those external resources. And what about namespace? Namespace isolate and secure them. So all the resources have their own spaces to work. And who will ensure that? That is the namespace. So basically, I'm not going to the details of that, but just remember, this is the environment of a container on which your image is going to run. So on top of it, maybe you have a base image of Ubuntu, base image of an Ubuntu software. Ubuntu is a Linux. Then you can add one more image, then you can add one more image, and then this is, you can keep on adding layer after layer. Okay. So a container is a space where you keep your images layer after the layer. And therefore, when you say that I have a container, that means you have some image, which is like it is some application or your application which can run inside the container. Why do we need this? The C groups play a role in containerization solutions like Docker and Kubernetes. You don't need to worry about all those things right now, but just say that the container has an environment inbuilt, which will help your image to run. You do not need to create your environment separately. You just have a container. It is like a plug and play software. You take it out and plug it in somewhere else, into some other platform. That's all. It starts running. You see? Now, the second part of this is, then you will say, what is a Docker image and a Docker container? Yeah, they are two different objects. They are the two different objects in the Docker lifecycle or ecosystem, you can say. One is the Docker image and the other one is the container. They are two different objects, but what I'm saying is a Docker image cannot exist without a container, and a container has no meaning without an image. You cannot have a container, a empty container. You cannot, because think of a ship. Will the ship run from one port to the other port? Can the ship depart from a port without with containers having nothing? That is not practical. Why should because it is a very costly transportation. You cannot send just a container. Container is just a layer, just a package. If you are presenting someone with something, some gift, you cannot present something with just the box without. So the person receiving that presentation unlocks or unpackages it and finds nothing inside. Is that good experience? No. So similarly, I cannot have a container without an image. It does not have any meaning. So once I put in an image inside a container, let's say I can have the same image. Let's say I have this Java application, which is created as an image, and I have stored into my Docker repository. Okay, or in my private in the account of my repository of the Docker repository. And this I'm putting it inside this container. I can have the same image put into the various containers, multiple containers. So I can have this Java application put into this container, and this container. So the size is 1 GB. So I'm putting this. What is the container size? The container size will be a bit more than 1 GB because you have this layer. This is, if I'm saying 1 GB, then this is, let's say, 300 MB or 30 MB. So 1.03 GB. A bit more because the environment, the container will have its own environment. So you put it. Okay, you put it over there. So this container becomes 1 GB size. And all of these containers are having the same image. That's also possible. So you say you are coming to a very important term called replication. So this container is a replica of this container. This container is a replica of this. So if this container goes down, at least you have this container and this container. If these two containers go down, so the same application is running on the third container. And it is by law, natural law, that the same thing cannot happen at the same time. Three containers cannot go down at the same time. Okay, or whatever. We will come to the concept of Kubernetes afterwards. You may please ask the questions if you think so. I have enough time. I've been given permission for the next session as well to continue the discussion. So don't hesitate. Please ask questions because that is very important for the success of this. We are trying to give you the best from this, the program. Now you can ask me, Debashish, why do we need containerization? What is the big deal in it? I will say yes. Then we have to delve into a bit of history, what happened earlier. First thing that came to revolutionize the particular application environment or IT environment, software environment or software application is virtualization. Otherwise, earlier, before virtualization, it was a bare metal. A big machine used to be there where it's like a big elephant. It is a very costly proposition. It was not very efficient. You have when you have a bare metal in one big machine, you cannot port in multiple applications. So it's a big IBM mainframe. It's a huge database running DB2 on which you are running only one application. Is that good? You are spending millions of dollars onto that particular machine and to that software or operating system, database, and one application you are running. However robust it is, but it is, see, today's competitive world is like it is microservices. The more and more you can build up your environment with microservices, you are the gainer, because today is a mixed hybrid world where you are not very happy with one product for long. So you can use that platform today with a Java application running, that's okay. But after maybe 1 month, there is a requirement of a Python application. So will I keep on expanding my infrastructure? The question is no. The answer is no, sorry. Because I cannot keep on capital investment, CapEx. And with the CapEx comes the OpEx, operational cost, because they are hand to hand. So the more investment I do in capital investment, the more is also the investment on my day-to-day operations. It it is an exponential curve. It grows on without your control. So those things are very resource hungry, and so therefore there is a very capital hungry. You have to spend a lot of money to stabilize the system because it's a big system. But that big system, the output, the throughput is very less. Yeah, they were very good for applications which are real-time applications like the telecom uh, applications. They have to run 24/7 all the 365 days without a single downtime, and huge number of CDRs hitting to that system. CDRs means call data records. In one second, there can be few millions of calls. Those sort of mission critical systems are very good, but that too is very, very costly for as an overhead. So we came to virtualization. The next jump from there came to virtualization. Why don't we think that we have a big server? Fine. So why don't we partition it? We put on a hypervisor. This hypervisor coming from different houses, big houses like Microsoft, Oracle. They came up with a solution called, okay, I will have the same machine. I will have the same host operating system, big operating system like Linux or something. And on top of it, I put in a layer of hypervisor. So what will it do? It will virtualize as if partitioning the entire. See, one big system is now partitioned into 3 systems with the full version of OS, guest OS. Yeah, but now you have a Java application, you have a Python application, you have a .NET application, Microsoft application. Earlier, with the entire big infrastructure, you could only have the one single application, either Java application or Python application, and that too also the porting of it, changing of it is quite difficult. But now at least you have you have utilized your infrastructure a bit better. You have made it one machine, 3 machines into one. So you are running 3 applications in one machine, one bare metal, and that is called virtualization. So virtualization is the process of running multiple virtual systems or resources on top of a single physical machine. That is one jump. You see, I have jumped. I made a quantum jump from what we used to have and what we are having now. We are better in a good position to utilize the same old machine with a lot of wasted resources. Now we are trying to optimize the resources by partitioning it virtually. These resources could be a storage device, a network, or even an operating system. So you can virtualize the operating system. You can virtualize your network. You can virtualize your storage device. So all of these applications are having the part of the storage device. Earlier, only one application was using the entire storage device and was not being able to share. So if the storage device of 1 petabyte or 1 terabyte, it was only using 20% of it. So rest 80% was left unused. That is not good. But now at least you are using 30%, 30%, 30%, at least 90% of your 1 terabyte, 90 GB, 900 GB. Yeah, 900 GB was being used out of 1 terabyte. So that is a good way. Now we come to containerization. Can you see that this application is having the full OS? This application is full OS. So I can say this application is good. I am having, instead of one application, with the help of hypervisor virtualization, I am having 3 applications running on the same machine. But these applications are heavily built because you have to have the full version of the OS. Now, somebody thought that this is okay for the time being, but in future, I need something else. So what they did, they had the same hardware, they had the same operating system, but they installed a container engine. Instead of hypervisor, we have a container engine. So now that engine, what the beauty of that engine is that, can you see the OS anymore? No. Every of this application, this is called container. One container, one application. Another container, one application. You can have hundreds of applications in the same old machine. Why? Because there is only, as I told you, the previous, this is the one. Okay, the C groups and namespace, that is the environment. So this is the environment. You need only the binaries and the libraries of the application layer of the OS. See, an operating system has 2 layers. What are the 2 layers? Can anybody tell me? Let's say Windows operating system, or better to discuss about Linux. The Linux will have 2 layers. What are they? An operating system, like a big operating system of Linux, will have 2 layers. The first layer is the application layer, the shell. You can say the shell. Okay. And the inner layer, another layer inside of it, is called the kernel. Here in this guest OS, you have both the application layer as well as the kernel. So it becomes too heavy. Okay, here you are seeing that the operating system is this one, that is part of the entire big machine or the infrastructure. But this, I do not have to have another operating system over here. I will just have the binaries and the libraries of the application layer, and I will use the kernel from the operating system. That's all. Why do I need to have another kernel over here, like the virtualization? So what they did is just extracted. They had this container engine can abstract a layer of application layer into this environment. That is the C groups and the namespaces. Okay. And this is, they have built the environment, and on top of it, you build your image. So this is one container with the environment and the images, the layers of the images that you have built in. Can you believe, if the size of this application is 1 GB or 2 GB, the same application, when you use the container as a containerized, can you believe what can be the size? Can you have a guesswork? Let's say this application, same Java application using the guest OS, is 1 GB in size. The same Java application with this containerization technology, what is the guess for you? What could be the size? Unbelievable. It will be around 30 MB. Can you compare 30 MB with 1 GB? Almost impossible. So if this is a 3 GB hardware, how many applications of 1 GB can be accommodated into this infrastructure? Only 3. Now, the same 3 GB architecture or system, how many applications of 30 MB can you accommodate? 100. Isn't it? You can accommodate 100 applications in vis-a-vis only 3 applications. So which one will I go for? Will I go for virtualization or go for containerization? Because remember, nowadays you are having the containerization, I mean the microservices. The world is moving from monolithic to microservices. We are having a slide over that. So containerization is the packaging of software code with just the operating system libraries, only the libraries, which is the application layer of the operating system, and dependencies that are required to run the code. So there will be some binaries and libraries of the application layer with dependencies that will be helping these images to run inside a container to create a single lightweight executable called a container. So this is container 1, 2, 3, and there can be hundreds of containers that runs consistently on the infrastructure. You pick up this container and put it in anywhere in any platform, it will start running. You do not have to set up an environment for that. Fantastic. This has actually revolutionized the entire thinking process. There is a paradigm shift from what you thought was a great achievement. Now you have another one. And this has really, it's a boom that came. That's why you have this Kubernetes, this large orchestration of microservices managed. So, and whom do I credit this? This guy, this virtualization, this containerization, who was the brain, whose brainchild is this? Linux, Red Hat. Red Hat Linux has started with the 7 point version of 7.0 version of Red Hat and the Ubuntu Linux. These are two very famous flavors of Linux, Red Hat and Ubuntu. They belong to two families. One is the Red Hat family, and that one is the Debian family. Anyway, so from Ubuntu 16.0 version and from Windows 8, containerization came into picture. So they are the first guys who started containerization. Linux introduced a concept of namespace and C group, the previous slide, to support the concept of containerization. Without the availability of this concept, namespaces are very important because they manage the C group resources. Every container is deployed in different namespaces. So this container will not clash with the container over here. They are residing in the same machine, but they do not have any resource contention because that is being managed with the C group and the namespace available with the containerization of the operating system or the Linux operating system. So once containers are created, they are very lightweight compared to the applications created on virtual machines, and we have discussed. Because the complete OS was installed occupying sizable amount of disk space, occupying huge resources like with the entire OS being installed over for one application, the OS will take up a measurable amount, a huge amount, enormous amount of CPU, memory, network, IO, input and output. So all these things are very heavy. This application becomes very heavy. And specifically memory. So fine, we move on. We understood the concept. We have understood the concept. Revolution in application deployment. This is a revolution in the real sense of the term. This is virtual machine. You see the infrastructure is the same. Where is the difference? Instead of hypervisor, you have the Docker engine or the container engine. Docker is one company. Can you see the application size? the binaries and libraries and the OS kernel, all will have to be there for this application to run, this application to run, this application to run. You have to have the full version of the OS installed again. Whereas you see, this size has considerably, almost 100 times reduced, because they are containers. Now, so what is the effect and what is the difference? So can you see, this is a Docker. This is a very friendly whale. Did you ever hear the term or the name of a picture called Moby Dick? There was a famous US movie called Moby Dick. There was a very friendly whale in the Pacific Ocean, or rather, I think in the Atlantic Ocean. Yeah. So that whale, some ship which is getting lost. This is a story behind what happened. So the ships that got lost in the Atlantic, because Atlantic had a very rough weather. So usually the ship would deviate from the route. That time, with this distraught ship came the Moby Dick. There's a white whale. It's a fiction, you can see, or rather a story. So there came the Moby Dick, so from somewhere, and it guided the ship to the particular route. So some ship who was wavered in its direction, so wavered from its own path, now had the help of that Moby Dick, who had guided the ship into the track. So the entire Docker, this is named after the Moby project, famous project, which has given the rise, which has given Docker to us. Okay. So this is the famous whale. So they have adopted the shape of the whale. This is called the Docker with the containers. So this whale is carrying the ship with guiding it in the correct path. So you can see the Docker has deployed your applications correctly, and the applications are put inside the containers. So where the Docker images, which is couple of MBs, the virtual machine images are couple of GB. So you can see the difference. Containers take seconds to start, whereas the speed of the virtual machines will take minutes to start. It is a bottleneck. When you come to today's applications, you cannot afford minutes, okay, for the application to be in picture. Yeah, I have crossed it out. Compatibility only with Linux distros. Distros means distributions. But whereas VM is applicable for all the operating system available in the market, that is with Linux, Windows, and and Mac. But this is not true. Now, what Docker has done is that they had made the containers. They are building the containers in such a way that it can be not only on Linux, it can be distributed on Windows as well as on Mac.